Alright, good everybody, this is Ajaks. Welcome back to my YouTube channel, and in today's video we are going to be looking at Lamis theorem and triangular law of what? Forces. So yes, we are going to be starting with Lamis theorem, and of course this is a JAMB video. Alright, so it's for those preparing for JAMB examination. Alright, as I'm going to be choosing JAMB past questions. So I want to just tell you something. Don't be in a rush to assume you know this thing. Alright, there are things I'm going to be exposing to you today that you might not have heard before. Are you getting me? So please follow me till the end. Just like I did in every of my videos, before I start treating past questions, I'll give you an insight of what the topic that I'm treating is all about. Alright, now let's start with Lamis theorem. So Lamis theorem. Now, what is Lamis theorem all about? What is Lamis theorem all about? Now, first of all, I want to tell you the conditions to use Lamis theorem. So it's not a rule or a theorem that you just pick and use anyhow. All right, now the conditions to use Lamis theorem, the first condition is that there must be three forces in equilibrium. Is that okay? Yes, there must be three forces in equilibrium. I hope you can see, that's what I'm saying it. All right, so please be writing. The second condition is that the forces, that's the three forces, must be coplanar. Now class, what's coplanar? What is the meaning of coplanar? Coplanar basically means they must act on a single plane. Is that clear? So let's write that down. I don't write on the board. They must act on a single plane. The third condition for Lamis theorem to be possible is that the forces must what? Be concurrent. Now, this is concurrent. C-O-N-C-U-R-R-E-N-T. Now, what's the meaning of concurrent? Concurrent basically tells us that these three forces, all right, their line of action must be at a point. So concurrent means the three forces line of action must be at a point. Must be what? At a point. So that's the meaning of concurrent. So once these three rules are in place, Lamis theorem is possible. Now please, I want us to pay attention, just like I said. Now let me explain something else to you. This is what we call sign rule. But before then, let me just draw how you are going to solve Lamis theorem. Just follow me. This is how it looks like. Let's say one force, another force, and another force. Are you following me? One force, another force, another force. Now let me name this F1, F2, F3. Follow me please. Now let's say this is theta 3, this is theta 2, and this is theta 1. That's the angle between each forces. All right, follow me. Now this is how to apply Lamis theorem. Lamis theorem use the rule of sine rule, but we call it Lamis theorem, but it's actually an explanation of sine rule. And that one is, we'll look at that one, move to triangular law of what? Forces. So please, you have a lot of things to do in this video. Just pay attention. Now, this is how to apply Lamis theorem. So applying Lamis theorem, this is how it's going to work. When you are applying Lamis theorem, you are going to now say that, follow me. One of the force, F1. Now, when you have picked that force, you now take the sine of angle between the what? The sine of angle between the two other forces. Are you getting me? So sine F1 sine what? Theta 1. Is that okay? To avoid confusion, let me just do this. Let's name this theta 2, and let's name this theta 3. All right, so theta 3, and let's name this theta 2. So F1 over sine theta 1 equal to F2 over what? Sine theta what? 2. All right, equal to f3, right? This one over sine what class? Theta 3. I hope this is clear. This is Lamis theorem. Get on. So anytime you are giving, we are going to solve a question now. Just follow me. And it's a popular JAMB question. We'll solve 2. Yes. Now, anytime you are giving any vector, the moment there are 3, the moment, actually most times they'll tell you forces in equilibrium, you can basically use Lamis theorem. And this is it. Alright? Now let's see example. Let's see an example so you can understand perfectly. Alright, now let's look at the question. So I did not clean this so we can just be relating to it, okay? Now I want you to pay attention. Now let me tell you something, Let me tell you something. These are the question. This is how this video will go. I'm going to use this one because this is like the general form. This is how your structure of your forces should be like before you can solve. But in the case of triangular law of forces, the structure is like a triangle before you can solve. So this is how this entire video is going to be like. I'm going to use this one. We explain Lamis theorem, then we move to triangular law of forces. Now I'm going to solve a question in triangular form there. What I will do is that I will now convert that one to Lamis theorem and convert this one to triangle. This video is going to be very interesting, so just calm down and follow me. Good. Now let's start with the question. Although you are going to see the question on your screen now. So the question was basically find T1 and T2 given that they are in equilibrium. Now let's solve normally. I want us to, the first thing to do in Lamis theorem is to map out your what? Your triangle, your angles. Yes, map out your angles is very important because you need angles now. So let's cram this, or let's write this down somewhere else. All right, let's write it down somewhere else because I'll soon clean that place. Now I want to map this out again. Follow me. Follow me. Sorry, this is not anything. This you get. So let me just give you a proper explanation of this question. So this is a tension. This is, we have different kind of forces. So weight is a kind of force. Weight is a downward force. Tension is an upward force. You understand? So this is tension, and this is weight. You can see weight is coming down. So please always note it. All right. So look at it. A tension. Please note. Note your direction of the tension and the weight and the forces and everything in Lamis theorem is very important. So don't just put it anyhow because it's important, because force is a vector quantity and vector quantity have magnitude and direction. Do you understand? So please, this should not be changed. Okay, that's my T1. Now a weight of 100 Newton. Are you following me? Weight is downward. Put it like that. Now this one, you take it up like this. You take it up. This is my T2. Now let's do the angle. I hope you know that this is a right angle triangle. So the angle here is 90. So if I do like this, you should know here is 90. Let me just put it because some of you are very funny. You might be asking questions now in the comment section. Just look at it. 90. All right. Now what's the angle full? What's this full angle here? It's very simple. Let's do it together. Follow me. If here is drawn like this, are you getting it? If here is 30, class, here we what? 60. Angle in a right angle triangle is 90. So 90 minus 30 gives you 60. Do you understand? Take it slow. If you don't understand, pause the video, go back, watch. That's why it's a video. All right. Now this is 60. Abi? Now if this is 60, what is here? 90. Class, 90 plus 60, 150. So it means the angle from here to here is 150. Abi? So just take it like this. 150. I hope this clear. Now, what's the angle from here to here? If here is 30, class, here is 90. Yes or no? Yes. 90 plus 30 is what? 120. It must, when you sum all the angles together, it must give you 360. Angle at a point. Do you understand? So that's another way to check if you are correct. Okay, so then you cannot do it in personally. I'm not going to do it. 150 plus 120 plus 90 gives you 360. Check it. Now let's go. 120. So you can see it now. It is now in this kind of form. Now let's apply Lamis theorem. Follow me. Let's apply Lamis theorem. Follow me. I told you this is F1, alright, over sine of the angle between the two other forces. So let's start. We are looking for T2, right? So let's take it. So if we are looking for T2 now, let's take it 2. It is senseless of you to come and be relating T2 and T1. Why? Because they are both unknown. So let's do a known and an unknown. What is the known, class? The known is what? 100. Are you getting me? So you say 100 over sine. Are you getting me? 100 over sine. Now what's the angle directly opposite 100? Take it like this. What's the angle? 120. That's the angle between the two other forces. This is 100. This is a force 1, force 2. What's the angle between them? 120. That's Lamis theorem. Are we getting me? Over sine 120 degrees equal to what? Equal to T2. Let's start with T2 now, Abby. Let's start with T2. T2 over sine what? What's the angle between T1 and 100? 90 over sine 90. Class, what is sine 90? Now let me just give you special angles. There is no space, so but let me just give you special angles. Please note all these things, so it's important. Just follow me. Now let me start with sine 45 degrees. So because we are JAMB students, just go with 2 over 2. Are we getting me? Sine 45 is root 2 over 2. As I'm writing, I'll be cleaning, so be writing down. Sine 60 degrees is what? Root 3 over 2. Sine 30 degrees is 1 over 2. Sine 90 degrees is what? 1. Sine 0, class, is what? 0. Are we cleared? So I'll just change all these things to cos. Alright, follow me. Cos 45 degrees is still root 2 over 2. Cos 60 degrees is what? 1 over 2. Cos 60 is 1 over 2. Cos 30 degrees is what? Root 3 over 2. Root 3 over 2. Cos 90 degrees is 0. And cos 0 degrees is what? 1. So please go and write them down in your book. Alright, now follow me. Sine 90 is 1. We just finished doing that now. So it means that T2, let me take it here, T2 over 1 is equal to, class, sine 120 is the same thing as sine 60. Why? Because sine is positive in the first quadrant. This is what I mean by first quadrant. I will have to clean. So please, I will have to clean. So please, let's just be following me. Alright, follow me. Now I have to clean. So this is what I mean by first quadrant. So let's say you draw a quadrant. This is the first quadrant, and all angles are positive here. Are you getting me? Second quadrant, sine is positive here. Third quadrant, tan is positive. Fourth quadrant, cos is positive. In the second quadrant, we are going to be looking at what? 180 degrees minus theta. That's for second quadrant. So if you are saying sine 120, second quadrant is all the angles that lie from 0 degrees to 180 degrees. This lies from 0 to 180. 120 is around somewhere here. You understand? So this is 120. Do you understand what I'm trying to say? So sine is positive here, tan is positive here, cos is positive here. Go and note. Don't worry, I might create a video very soon on quadrant. You just take note of it. Okay? Now, sine 120 is the same as sine 60. You can check on your calculator. And what is sine 60, guys? Sine 60 is what? Root 3 over 2. So 100 divided by root 3 over 2. Class, now let's compute that. I don't want to clean this equation, right? Follow me. 100 over root 3 over 2. So we have my T2 to be equal to what? 100 over root 3 over 2. So that's the normal calculation. 100, are we getting me? Times 2 over root 3. Do you understand? 100 times 2, class. 100 times 2 is 200. So my T2 is what? 200 over root 3. Now, if you rationalizing basically means multiplying the denominator by the fraction. So, by rationalizing, I'm saying root 3 over root 3. Do you understand? So, my T2 is now what? 200 over what? 3 root 3 Newton. This is the value for my T2. That's true. Alright? Value for my T2. So, either you put it anyhow you want to put it, either you put it in decimals, is your business. We don't have time for that. Alright? So, this is my value for T2. Are we clear? Now let's apply Lamis theorem again to find T1. So we are leaving this. Okay, no, we're not leaving this like this. Just follow me. So for T1 is going to be 100 over sine 120. Are you following? Equal to what? Equal to T1, sorry, over, now what's the angle between T1 and each other angles? 150. So look at it, 100 over sine 120 equal to T1 over what? Sine 150. Now follow me. What is sine 150? Sine 150 is the same as sine 30. 180 minus 150 is 30 now. Are you following? So what is sine 30? 1 over 2. Now T1 divided by 1 over 2 is 2T1. So let's go. 2T1 equal to 100 over sine 120. 100 over sine, I think we did something like this before. Yeah, yes. 100 over sine 120 is 100 times 2 over root 3. And that gave us 200 root 3 over 200 over 3 root 3. Okay, let me just calm down because people might say I'm rushing. Follow me. 100 over sine 120 root 3 over 2. Abi no be so? No be so? Root 3 over 2. I hope I am not making a mistake here. Okay, I'm not. So root 3 over 2. Now, what can I do? What can I do? What can I do? Okay, let me first compute this place. Let me compute this place. I can clean question now. We are done. Follow me. Follow me. I want to compute that place. So 2T1 equal to 100 times 2 over root 3. Class, 2 cancel 2. What is my T1 finally? 100 over root 3. By rationalizing, this gives me what? 100 root 3 over 3 Newton. Okay, in case you don't know what means of rationalizing, let me just quickly explain that. Rationalization is swords, all right, and this is physics. But let me just help you. So to rationalize, what you basically do is to multiply the denominator. So let's say we add T1 to be 100 over root 3. Now you multiply the denominator by the fraction up and down. Are you getting it? My T1 is now 100 root 3 over, now root 3 times root 3 is same thing as 3. Do you understand? Root 3 times root 3 is 3. I hope this is clear. So this is Lamis theorem. It's simple. Forget, because I'm teaching you, that's why it looks hard. All right. When you do it on your own, you'll be very fine. So yes, in conclusion, my T1 is 100 root 3 over 3, and my TT is what? 300 over 3 root 3. Abi? Yes. I hope this is clear. So yes, in case you enjoyed the video, do have to subscribe to our channel. And yeah, let's move to triangular law of forces. Then when we do a question on triangular law of forces, what will now happen is that we'll now do one more that will solve in both ways. Yes.
Hello, aspirants. Have you heard of Ajaks tutorials, the #1 educational consult and tutorial in Nigeria? We are a group of highly intellectuals who impact experience and help them get into their dream universities. The tutorial is headed by Ajaks Joseph, the CEO, with other experienced tutors. We offer a wide range of academic services and materials. To get into your dream university, contact us through our official WhatsApp line displayed on the screen. Here is our track record over the past few years, and has all secured admission into their dream universities. We can do same for you. We are Ajaks Tutorials. Join us today.
Alright, now guys, welcome back. So let's look at triangular law of forces. So yes, we in the previous example, we actually did what? Lamis theorem. Alright, now let's look at triangular law of forces. So like I said, this video is very important, so please don't skip, calmly listen. Now this is a JAMB question you have on the board. You're also going to see it on your screen in case this is not clear. Can you see that? Good. Now let's go. They are asking you to find the value of t in the above. Just look at this like, what is this one? How can I find t? It's simple. It is very simple. And that's what we're going to be looking at today, triangular law of forces. So yes, it is similar to Lamis theorem, but there's something that you should note. Now let me state it. Triangular law of forces, I don't want to write, there's no time. Triangular law of forces states that when three forces are in equilibrium, are you getting me? They can be expressed in magnitude and direction by their what? Their sides taken in order. Now, sides taken in order. First rule when you want to solve for triangular law of forces, the first rule is to ensure that the direction of the force is not changed. So this means that even if the force is appearing to you like this, your question, or like this, is the same thing. Don't change it. So because the rule states that the magnitude and direction can be expressed by the sides of the triangle taken in order. So regardless of how it looks like, please don't change direction. What is direction, Ajaks? This is direction. This is direction. This is direction. I hope this is clear. Good. Now, what's the second rule using triangular law of forces? So what I'm telling you will really help us in calculation. So please open your ears. Good. Now, the second rule to use triangular law of forces is that the angle between the force and the horizontal should be used. Yes, the angle between the force and the horizontal should be used. Okay, now I am not necessarily saying that if you use the angle between the vertical, it is wrong. This is a channel, this is a YouTube channel, it's a video tutorial to help students. I will teach you what I know. I will teach you what is best that I use. So I'm not saying using vertical is wrong, but if you want to go with my method, to me I think it's the best to use. All right, because vertical can be confusing. So please, the angle between the force and the horizontal should be used. And lastly, three forces must be involved in equilibrium. Good. Now, once these three rules are met, my brother, my sister, you are good to go for triangular law of forces. All right. Now let's solve this question that we can see on the screen, on the board. Sorry. Follow me. It's very simple. What's the value of t in the above? This is a JAMB question. All right. Now the first rule is that take it in order. No go do over sabi. Now what we are doing in triangular law of forces is that we are trying to form a triangle from forces. That's why the force is meant to be 3. There's no way you want to form a triangle with 4 forces. That's not like, that's now a quadrilateral. A triangle is a shape with 3 sides. And for you to get 3 sides, it has to be what? 3 sides. Are you getting me? Good. Now, let's start with this T. Is that clear? Don't change the order. Anyone you start with is fine. Alright? If I want us to start with this guy. Start with it and tell me if you got in the comment section. Okay, don't forget to good. So this is what T. Alright. Now before you put the angle, first of all, let's do this thing. Alright, it's important. So let's go. I'm using red to put angle so you will not get confused. Follow me. What's the angle between T and the horizontal? 30. Are you getting me? Now after that, what else? Let's go with this guy. Okay. Listen. If I want to use this one now, that means I'm coming like this, but there is no really much space now. So let me not use this one next. Let me use this one. 20 is coming down, Abi. So let me increase this thing. So the triangle will be big. Alright, so this is my T. Now 20 is coming down. Yes or no? Yes or no? Yes. So if 20 is coming down, 20 Newton. What else? This guy is coming up as 30. Now look at it. Most people actually wanted to form a right angle triangle. I never told you this is meant to be a right angle triangle. It's a normal triangle. It can be right angle, it can be normal. Now this is what you should do. The moment you are saying that, because if I want to take this one now like this, see, look at it, this one like this, I mean this one like this. Now if I want to take this one like this, the triangle is going to be half k leg. So what I will do is I'm going to reconstruct again. All right, I'm going to reconstruct again. I will take this down a bit, I take this up, take this as t. Are you getting me? Now what I will now do is I will now bring this one down, because we are trying to form a triangle. You're not doing anything wrong. 20 Newton. Are you getting me? Good. Now what's the angle between this guy? Don't forget 30. Abi, let me do the angle like this, so you're not going to make mistake. 30. All right, now class, follow me. This is it here, right? So continue from here. So from here we went here, that's t, then we came down, that's this one, then what else? We are coming up again. Your turn. And what's t? Oh, all right, good. So what's t, class? Me and man artist to pele no go vex. So what's t? T. Are you getting it? This is a triangle. Now after that, we have to also look at the angle. What angle did this t make with the horizontal? 30. So look at it. This is where the whole trick comes in. Now you're not going to put 30 here. This is it. This is the 30. Class, is it sensible to use this 30? It's not in the triangle now. So you use this one here. And what will be here? 60. It don't. If here is 30, what will here be? If here is 30, what will here be? Now, this place is not 30 because here is 30. Are you following me? It is not 30 because here is 30. Now look at it. This place is 30 because this is alternate to this. Alternating angles are equal. So because this angle is, see it here, this one is alternate to this one. So this is the 30 and is equal to here. So that's why here is 30. And that's why everything here will be what? 60. Is this clear? Good. Now, class, we have successfully gotten all the angles in a triangle. Now, you might be wondering, how is that impossible, Ajaks? How is that impossible? How is here 60? How is here 60? What is now this place? The angle in a triangle is what? 180. So bring your calculator out, guys. Let's go. 180 minus 60 minus 60. That's going to give me what? 60. Put 60 here. You have successfully drawn a triangle. I hope this is clear. So don't look at this thing. You understand? This is not drawn to scale. So this angle might be looking bigger. Is correct. You are correct. We are correct. Okay. Now what I want us to do is to solve. First of all, I want to do something. See, the reason why this thing looks long is because I'm teaching you. It's not long at all. Just follow me. Let's redraw all this diagram properly again, okay? I'm not changing anything new. My t, right? This is 60 degrees. Abi? 60 degrees and 60 degrees. Alright? This is coming like this. This is my t again. This is coming like this, my 20 Newton. That's all. So we are asked to find t. Now this t and this t, they are the same thing, so we don't need to bother ourselves. We just find one. Class, sine rule. Yes, we are going to be using sine rule in this question. And now in the Lamis Theorem video, I told you it has an application with sine rule, but this one I'm going to do pure sine rule. So now go from sine rule. Yes. from sine rule, we are going to have that 20 over sine. What's the angle between the angle opposite 20? 60 is equal to t over sine. What's the angle opposite t? 60. That's sine rule. All right, now let's solve normally. What is sine 60, class? Sine 60, fact. This is sine 60, this is sine 60. If you say 20 cross multiply sine 60 equal to t sine 60, what will my t be? Cancel. My t is what? 20 Newton. So my value for t is what? Option C, correct. JAMB question, very simple. You can see there are many things that we could have bypassed. Number one, JAMB did not now give you the stress of doing sine. So if you understand how to do this well, you are good to go. I'm telling you, it's simple. What you just need to do is, when you get your question, just draw the triangle in order. See, from here like this. Now from here you take this one down. If I want to say, okay, let me look at it. I want to do something because I really want us to get it clearly. You know, I told you, do it and send to the comment section. Let me just help you. Follow me. Let's start with 20. We start with what? This one first, Abi. Now let's start with this one. Abi, coming down. Right? Now this one, there is no angle because it is a vertical. So the angle there is 90. Do you understand? So when we are coming down like this, now where should we go to? Let's bring this down a bit. So let's go like this. See. And what's the angle? See, what's the angle to the horizontal? The angle to the horizontal is 30 for this one. So if here is 30, here is 60. Do you understand? Now after this one, Abi, then now this one came like this. See, and what was the angle to the horizontal for this one? 30. Follow me. 30. Now the reason why here will now be 30 is because here is alternate. So we are doing the same thing. If you decide to start with this one, do like this. Abi, when you do like this, let me say I want to use, okay, if I do like this, I want to use this one, Abi. After this, I want to use this one. From like this, go like this. T. What else? Come down. The same thing. So regardless of any side you start with, my brother, you are good to go. So I hope this is clear. And if you are enjoying this video, please subscribe. All right, that's what will encourage me to do more videos. All right, yes, subscribe to the channel Ajaks Tutorials. And if you want to know more about the tutorial, check the description below for our website. Okay, now let's continue. So that is it. We are done with this JAMB question. 20 Newton is the answer. I hope it's clear. Now let's solve one more, and that question we are going to be fast with it. Number one, and we are going to solve it in two ways. So start with Lamis theorem, then we'll now convert it to triangular law of forces. Okay, all right, now welcome back, guys. Now let's look at this particular question. So the question is going to appear on your screen now. So this is it. Now we are going to use triangular law of forces to solve this. In the beginning part, we used the same example. The difference was just that this place was 100 and here is 10. And now let me tell you, this is another thing to watch out for. Before you start any question on Lamis theorem or triangular law of forces, ensure that all your forces are consistent in units. They must be in Newton. Because now look at this, 10 kilogram. You might be just carried away and use 10 like that, you fail it. Do you understand? So please always convert this to what? Newton. And W equal to mg. Do you understand? W equal to mg. There's something funny about this question I will explain later. Just follow me. So what's my W? My W is 10 times 10. If you are not giving the value for G, please use 10. You are a JAMB, you're not a 100 level student. All right. So this is what W equal to what? 100 Newton. Now have it in mind that this place is 100. So when you are solving, use 100, not 10. Are you following me? Now there's something that they did purposely in this question. In fact, that's why I brought it out here. It's funny for most students that are not paying attention to what I've been saying before. Now this is how the question appears. I will send to your screen now. You can see that they did not give you direction. It is intentional. It's not a mistake. Follow me. They only gave you that this one is going like this. Now what of this one? what of this one? How do you think a string will be pulled that is attached to a wall? How do you think it will be pulled? Towards the wall. So this is how the direction is. You put it by yourself. That's why it's good to know book and no concept. Are you following? So you don't fake questions. Now what of this one? This is mass, and we just found weight. If you go and put this one up, then I will give you hot knock. How is mass? Weight is a downward force. So just put it down. You are done. I hope it's clear. So I'm just making sure that you get a not fall trap of JAMB tricks. Okay. Now let's solve normally. We're not going to use Lamis theorem because we have done it before. All right. Now I want us to be sincere in heart because I want to give you an assignment and I want you to drop the answers in the comment section. Be sincere in your heart. I'm going to solve for T1 and you solve for T2 sincerely, and you tell me the answer. All right. Good. Now I'm going to solve for T1, then you solve for T2 sincerely and type your answer in the comment box. Okay. Now let's solve. I want to use triangle of forces. So which one should we start with? Let me start with the weight. Weight coming down. Are you getting me? 100 Newton. Are you following? What else? Weight coming down. Then this one, where should we go to? There is more space here than here. So let's go like this. I mean, to carry this one like this. So this one is meant to be straight too. So it's meant to be straight. Like there's an angle there, but the angle is 0 degrees. Okay, let me tell you something. When the angle is to the horizontal is 0, when it's to the vertical is 90. Let's continue. So take it like this. All right. T1. Are you following me? T1. Now we have gotten T1 now. What else? You take this one up. You can see it coming like this, coming like take this one up. So take it up. It must form a triangle. Now imagine you assumed that this one was going like this. Imagine it was going like this. How will your triangle be like? Your triangle be like this. One, this one like this, this one like this. Is it a triangle? It's not a triangle now. There is no way that you want to bring this one here since it's like this. So please, tension is always like this. All right. In fact, let me tell you something safe. When you get to 100 level, for the engineering students, you're going to do what we call trusses. So it's what we call tension and compression. Compression is inward, tension is outward. So this is the string, tension is outward, tension is outward. Do you understand? Compression is inward, so tension can never go in, it's out. Is that okay? Good. So let's continue. Now you're going to take this one from here, you merge it to this place. That's your T2. So let me just try. Good. T2. That's all. Now that's not all. Sorry, your angle. This one is at 90, so it's okay like this. This one now 0. So form a right angle triangle now. Okay? Good. Then what's the angle between T2 and the horizontal? Don't go and put 30 here. You have to be careful. The angle between T2 and horizontal is 60. Do you understand? So 60. That is all. So how can I find my T1? So toi. Class. So toi. So toi. Let me just help so for some of us I don't know it. So is sine theta equal opposite over hypotenuse. Cos theta, that's k, is adjacent over hypotenuse. And tan theta. Tan theta is what? Opposite over adjacent. Now, don't be bothered, don't be ashamed. This is why this is a video tutorial. Let me teach you how to find opposite adjacent hypotenuse. Okay? Now, when you have a triangle like this, me, the longest part is hypotenuse. So this is hypotenuse. Now, your opposite and adjacent is dependent on where the angle lies. If the angle is here, the side that is directly opposite the angle is my opposite. So which side is directly opposite the angle? This place. So this opposite. If angle is here, this opposite. Then that side is adjacent. I hope it's clear. So class, what are we using? I say I'll find T1, you find T2 and drop answer in comment section. So this is what the angle is here. This is my opposite. Then this is adjacent. Adjacent and hypotenuse. Adjacent and opposite. Abi? Adjacent and opposite. Adjacent, opposite. That's tan. So tan 60 degrees is equal to what, class? Tan 60 is equal to opposite 100 over T1. I forgot to put tan. Oh, sorry. You know I gave you just sign. I forgot to put tan. So let me just give you now. Tan 45 degrees is 1. Tan 60 degrees is root 3. Tan 30 degrees is 1 over root 3 or root 3 over 3 when you rationalize. Are we getting me? Then tan 90. Tan 90 is undefined. Undefined. So don't worry, you know that better when you move to 100 level. Okay? Let's continue. Then tan 0 is 0. B? Tan 0 sine. Yes, tan 0 is 0. Okay? Tan 0 is 0. Just write it out. So what is tan 60? Root 3 equal to 100 over T1. Class, T1 is now what? 100 over root 3 Newton. What is my answer, class? Option B. So please, I hope this is clear. I have tried and I've explained and broken down everything you need to know on triangular law of forces and what Lamis theorem. Thank you very much. I meant see you Ajaks tutorials. Please do well to subscribe to this channel and share. Don't want your friends to learn. If you're a 2025 JAMBite, if you're a JAMBite at all, because I don't know when you're watching this video, I don't know the year, but if you're a JAMBite, if you're a student, if you're a post-UTME student, and you want to know more about Ajaks tutorials, check the description below for our website. Thank you very much. Bye.